Spinosaurus is one of the most unusual dinosaurs ever discovered, not simply because of its size or appearance, but because even after more than a century of research, scientists still cannot fully agree on what it truly was. Over time, this animal has been reconstructed, reinterpreted, and reshaped again and again, making it less of a fixed prehistoric creature and more of an evolving scientific mystery. The story begins in 1912, in the deserts of Egypt, where fossil remains were uncovered and later studied by the German paleontologist Ernst Stromer. By 1915, Stromer had described the species and named it Spinosaurus aegyptiacus, meaning Egyptian spine lizard, based on the animal's most striking feature, its enormous dorsal spines rising from its back. Even from the limited fossils available, it was clear that this was not a typical dinosaur. However, the skeleton was incomplete, and scientists had to rely heavily on comparisons with other theropods, especially large predators like Tyrannosaurus rex, to fill in the gaps. This approach led to early reconstructions that portrayed Spinosaurus as a large, upright, bipedal predator, similar in overall posture and behavior to other carnivorous dinosaurs of its time. Yet, certain features did not quite align with this interpretation. Its teeth, for instance, were smooth, conical, and lacked the serrations seen in most meat-eating dinosaurs. These teeth were better suited for gripping rather than slicing, suggesting a different feeding strategy. Additionally, its long, narrow snout bore a closer resemblance to modern crocodilians than to the deep, robust skulls of typical theropods. These details hinted that Spinosaurus may have occupied a unique ecological niche, but without more complete fossils, these ideas remained speculative. The situation became even more complicated during World War II, when the original Spinosaurus fossils stored in Munich were destroyed in an air raid. This loss removed nearly all direct physical evidence of the original specimen, leaving scientists with only Stromer's notes, drawings, and a few photographs. For decades, Spinosaurus remained one of the most enigmatic dinosaurs, its true nature obscured by missing data and limited material. It was not until the latter half of the 20th century that new discoveries began to shed light on its identity. Fossils of related dinosaurs, such as Baryonyx and Suchomimus, revealed animals with similar skull shapes and tooth structures, and in some cases, direct evidence of fish consumption. These discoveries strongly suggested that Spinosaurus belonged to a group of dinosaurs adapted for a fish-based diet, indicating a possible connection to aquatic or semi-aquatic environments. A major breakthrough came in 2014, when paleontologist Nizar Ibrahim and his team described a new Spinosaurus specimen that included parts of the spine, limbs, pelvis, and skull. This was the most complete set of remains discovered since the original fossils were lost, and it dramatically changed the scientific understanding of the animal. The new evidence showed that Spinosaurus had unusually dense bones, a characteristic commonly associated with animals that spend significant time in water, as it helps with buoyancy control. Its legs were shorter than previously thought, and its body appeared elongated and positioned closer to the ground. These features suggested that Spinosaurus was not built for fast terrestrial movement like other large theropods, but instead may have been adapted for stability in aquatic or semi-aquatic environments. Its broad, robust feet further supported this idea, as they could have helped distribute its weight while walking on soft, muddy surfaces, similar to modern wading animals. In 2020, another remarkable discovery added to the growing complexity of Spinosaurus. Scientists described a nearly complete tail that was tall, flexible, and shaped in a way that resembled a fin. This tail's structure indicated that it could have been used to generate propulsion in water, providing strong evidence that Spinosaurus was capable of swimming. This finding led to the hypothesis that Spinosaurus might have been one of the first known fully aquatic dinosaurs, actively hunting fish in rivers and coastal environments using its tail for movement and its elongated jaws for capturing prey. However, this interpretation did not go unchallenged. Subsequent studies questioned whether Spinosaurus could truly function as an efficient swimmer. Some researchers argued that its body structure and buoyancy would make deep diving difficult, while others suggested that its center of mass and limb proportions were better suited for walking than for sustained swimming. As a result, an alternative view emerged, proposing that Spinosaurus was primarily a shoreline predator. In this scenario, it would have spent much of its time in shallow water, wading or standing at the water's edge, using its specialized jaws and teeth to ambush fish and other prey. This interpretation aligns with many of its anatomical features, while avoiding some of the challenges associated with a fully aquatic lifestyle. Today, Spinosaurus occupies a unique position in paleontology. It clearly shows adaptations related to water, more so than most other known dinosaurs, yet the extent of those adaptations remains uncertain. Whether it was a fully aquatic swimmer, a semi-aquatic hunter, or a predominantly land-based predator with specialized feeding habits is still a subject of ongoing debate.